Excellent. Thank you very much. I guess I'd like to start by saying that I'm not a big company. I'm not a small to medium enterprise. I'm just a person, and I've been the victim of a ransomware attack through the QNAT hack. So it happens everywhere. It touches everybody, cybersecurity. But that's not what I'm going to talk about today. Let's see how we go. So I thought I'd start with, so I'm from Flinders University, and we've had I'll try and stand still, a small and growing and shrinking machine learning AI group at Flinders, and I tried to capture some of them here that exist there, where we're all working with different aspects of it, fundamental sort of mathematicians and statisticians through to people like Paolo, who is here today, working in AI and robotics. We've had some successful spin-outs, such as Your Amigo, which is more of an intranet search engine, as well as Clevertar. If you've visited the SA Health website and noticed a little talking character down the bottom, that's a conversational agent come out of Flinders. Product placement down the bottom. So recently we've started our Bachelor of Computer Science in Artificial Intelligence, as well as starting up a Master's of Computer Science in Artificial Intelligence. And that, I guess, it could be a launch pad for people who have already studied computer science and want to specialize into artificial intelligence and machine learning. So that would be a 2-year degree in that place. So there we go. That is my product placement. And okay, down the bottom, Mawish has recently joined us, and hopefully we'll get to do some fun machine learning AI type things with her as well. So Mawish came to me and said, let's give a talk, and we sat down and sort of thought about what could we talk about, what could I talk about and contribute to today. So I came up with this title, AI for Enhancing Workflow Through Predictive Analytics. And I'm not sure what that means either, but essentially I wanted to talk to you about some of the projects that I've been working on, which are listed up here, but most interestingly, the 3 in green here have only come about in the last 12 months, if that. Maybe it's because the pandemic and people have been sitting around staring at their navels, wondering what they're going to do because they can't actually go out and collect data. So how can I look at my own data? Or is it because machine learning is starting to become part of the vocabulary of different research groups? And so those 3 in the middle, so this year, essentially people have been coming out of the woodwork saying, hey, I've heard about this machine learning AI, how can we use it to deal with our data? So the first one, talk about what we call Psychosis Diagnosis. And this is a project we've been working on for, I hate to say it, about 20 years. First looking at brain signal analysis of people with epilepsy, trying to see if we can see differences. And that was using fairly standard statistical techniques, investigating that. And through the data set that we'd collected, we started to notice some interesting features with other disorders. And so people with psychoses, so schizophrenia, bipolar disorder, we started to see that there were some interesting features within their brain rhythms. And these particular diseases, the only way currently that you can identify them is through people having multiple episodes of the psychoses, through background history. And so there's no real biological marker for that. And so through, I guess, data analysis and using machine learning, so up there I have artificial neural networks and support vector machines. So taking this data and being able to classify it, we're starting to see that we might have something that we can actually use in a clinical setting to aid that diagnosis. So this can't be done in a silo. And I think that'll be my message through all of this, is that it requires computer scientists biomedical engineers, neurologists, psychiatrists working together to understand this. So machine learning experts in the room, we can look at the data, but do we understand what the numbers actually are? So we need the multidisciplinary teams to be able to solve all of these problems. So one of the new ones that's come about is looking at confidence in earaches diagnosis and using machine learning to do that. And so this is one of the ones where I really thought about the title of this presentation, which is enhancing the workflow. So the story behind this one is that out in remote communities, the incidence of ear infection is quite high, and there's a lot of community workers who triage the patients, which happen to be children, through there for referral onto the medical experts, the ENT and the doctors. The issue arises is that they don't want to miss any diagnoses. So most of the children are sent on for further referral, which they don't really need to be. And so the idea here is to increase the confidence of the community workers who aren't specialists in ear and otitis media diagnosis, but to give them another measure that they can use here. So we have these images which have a healthy ear, a infected ear, one with some goo coming out, and another one that has a grommet in there as well. So these are the types of different images that we work with. Convolutional neural networks, fantastic. But one of the other interesting parts of this is that's not the only data. There's more data that we can use, and it's not image data, it's other types of data. And so we can start to combine and fuse that information together, which is quite exciting. Another project which has just come about, slightly different, no images in this one, is predicting the risk of dysphagia. So especially post-extubation dysphagia. So dysphagia is trouble with swallowing. If you have a serious accident, you need to go to hospital, you're in a coma, you'll have a tube put down your throat. When they take that out, you can have trouble swallowing. So identifying this is very important. And sometimes it's obvious, but there's also silent dysphagia where there's no obvious signs of it. So you eat and drink, you end up getting food and water in your lungs, and that causes serious problems. So being able to identify the risky patients and putting treatment around that, but also those who aren't at risk and not having to spend time with those people. And so here we're looking at trying to predict the risk of it. And we have a nice data set of across 9 years of emergency department data and about 16 million records, which we can't open up in Excel. So I guess maybe that's one reason why they came to me. Please, Trent, help me with that. And so this is working with speech pathologists, nursing staff, computer scientists, and looking at how we can tackle this and get some interesting information out of it. And again, optimizing that workflow. So knowing which people we need to look after and which ones we don't need to. The interesting aspect of this one, and I think I've heard it a couple of times today and across the 3 days, is that this type of analysis needs to be clinically explainable and actionable. So we can't just have a black box neural network taking some numbers in and spitting some numbers out. We have to understand why it's made that decision. We need to be able to explain that decision. So we need to think about algorithms that we can do that with. So I've just thrown a few up there: decision trees, association mining. So we need to look at different techniques to be able to deal with that through there. Another one is falls prediction. And this one is, I've got some numbers up here. So over 12 months, nearly 1 in 3 older Australians have a fall. In residential aged care services, it's 50%. So it's quite a lot. And when an older person has a fall, then there's a lot of risks associated with that. you have a broken hip, and that's going to change their lifestyle. So this isn't falls detection, it's the risk of a fall. So predicting when it might happen and being able to put in measures to work with that. And so what's the interesting things here? I guess we're working across management, plus the allied health, physiotherapists, nurses, and computer scientists in the aged care sector. And it's also integrating across different data stores. So a lot of this information isn't just stored in the one place. So the dysphagia, it's all in the medical records, but this one we have risk assessment databases that stores all the falls, when it happened, all the information around it. Plus we have clinical data, which is so the physiotherapist reports, the doctor's reports, and trying to bring that together into a central source and analysing that. Again, these ones need to be clinically explainable, so we can't just throw it into a black box and hope for the best. We need to be able to understand the information or the models that are coming out of it. What have we got next? Oh, okay. What have we got? Lunch next, or coming up? No, it's not. Oh, I can keep going forever then. All right. So this final one here, I guess this one was interesting. A group of people, so psychologists, palliative care, computer scientists. This one came about after a late night discussion with the head psychologist on this project and the computer scientist about looking at web-based conversations around death. And so this was a MOOC that was run, and during the MOOC, there were touch points for people to express their feelings about death through words. And the conversation was about, the psychologist was saying, hey, we're going to look at this and try and go through this, and we're going to look at each word, and we're going to try and get an idea of what the feeling was behind it. And I said, really? You're going to do that? You're going to look at that? I said, no, a computer can do that. No. I said, yes. And so I said we could do sentiment analysis and automatically, and the key thing I think is objectively place a sentiment value on that. And the approach we finally went with is looking at variance, arousal, and dominance, so three-dimensional approach, not just a positive, negative sentiment, which gives you a nice, more interesting look at the different types of words in here. And we can see the plot on the side in terms of arousal. Death is highly arousing. And the details, you can have a look at the PLOS One paper that we managed to publish with it. But essentially we could capture this sentiment of people through their conversations through there. And to do this manually would have taken a long time. So it was increasing the researchers' workflow through using machine learning. What have I got? So they're the sort of projects that I've been involved with. The two on the either side, a bit more longer running. The ones in the middle, again, are new opportunities that are arising through larger data sets. So I guess the research tools I use, I live in the universities in the ivory tower. So MATLAB is wonderful, but expensive. Also play in the open source space, which is, recent times, Python and everything supporting it is a very valuable and accessible way to use machine learning. If you're in the real world, having to make real products and deploy them at scale, then the big players, as we've seen, I've seen these words already thrown around. So AWS have a machine learning stack that you can tap into and again deploy at scale. Microsoft Azure services also have a lot of these as well. This is a cool little ML cheat sheet that they have. So what do you want to do? Figure out what you're trying to do, and then you can find your classifier or technique that you want to use for that. So that's, I guess, the end of the talk. Again, once product placement up there. My take home for small to medium enterprises is essentially that you may be generating data, and I think a lot of companies are these days. We're instrumenting quite a lot of different processes. So you're generating that. Let's understand it. How can we understand that data? And team up with AI ML specialists. So I guess that is, Data 61 universities, and trying to understand it. If you're on the other side of it, you're upskilling into AI ML, maybe you could put some of your staff through a Masters of Computer Science and AI, just saying. And then you can partner with domain specialists who are generating that data. And so I guess from my experience just in the last 6 months that people are being more and more interested in this space. So it's a growing area. So if you can have that expertise, it's excellent. And I guess collaboration is key. I can't do my machine learning work without the domain experts to work with. So collaboration is definitely key in this space. And the last bit I want to touch on is data. And it's always part of it. It's fun to play with the machine learning algorithms, but you still need to think about, I guess, these 3 parts down the bottom here, which are data privacy and ethics. We've touched on it again through some other talks as well. So it's people's data, possibly. So you've got to handle the privacy, the ethics of it. What are you going to do with that? Is your data biased in some way? There's lots of good things to think about when you talk about ethics in machine learning. Data sovereignty. So this is where is your data and where are you storing it? If you start using some of these AWS and Azure, where is your data going? Is it in Australia? Is it being hosted somewhere outside of Australia? And do you care? But where is that data? And data ownership as well. So who owns it? Do you own it as the company collecting it? Does the individual own it? Who owns the models? Who owns the results? So I guess some food for thought in that place. So I think, AI for enhancing workflow through predictive analytics is sort of what a lot of us are trying to do, is to enhance what we're trying to do. And collaboration. So I hope I get to collaborate and chat at least with a few people here. Thank you.